We have just learned one of the important applications of Euclid's division lemma. And what was it? We could very easily and systematically find HCF of two large positive integers. And now it's time for us to look into some of the other applications of Euclid's division lemma. Remember, in the first lesson we discussed that a lemma is a small proven statement used to prove other statements. Now, since Euclid's division lemma is a lemma, we will be using it to prove other theorems. For example, it can be used to prove some of the fundamental theorems, which is now very common knowledge. Now, all of us know that any even integer can be expressed as 2q and any odd integer can be expressed as 2q plus 1, right? Where q is an integer. Now, this simple fact can be actually proved using Euclid's division lemma. So let's see how this is done. For our conceptual understanding of Euclid's division lemma, we can express any number a as a equals bq plus r, where 0 is less than or equal to r less than b, meaning remainder is always less than divisor and has to be greater than or equal to 0, right? So this is something that we all of us know. Now consider some integer a and let b be 2. So our expression becomes a equals 2q plus r. Now what are the values that r can take? Since r has to be less than the divisor, that is 2, r can only take values 0 and 1, which means the integer a has to be either of the form a equals 2q plus 0 or a equals 2q plus 1. That's it. So any integer can be expressed in the form of a equals 2q or a equals 2q plus 1. If the integer is in the form of 2q, it means that it is an even integer. If the integer is of the form 2q plus 1, it means it is an odd integer. That's as simple as it is. It was that easy to prove this simple fact, isn't it? Alright, so let's look at one more application question to seal this concept perfectly. Okay, so here is your question. Adarsh wants to cut a rectangular board into identical square pieces for his project. If the board is 54 centimeters by 90 centimeters, what is the dimension of the largest possible square pieces that he can cut without wasting any of the board? Okay, so how do we solve this question? The question states that Adarsh wants to cut a rectangular cardboard into identical square pieces. What does this mean? It means that he basically has to cut the board into pieces that are equal in length and width. And he has to do this without wasting any of the board. What does this mean? It means that he has to choose a side length that will divide evenly into 54 and 90. And we are asked to find the dimension of largest possible square. This means he has to choose the side length. He has to choose the largest possible side length that will divide evenly into 54 and 90. Now, does this statement ring any bell? Yes. It is HCF of 54 and 90 that we need to find, because HCF is the number, HCF is the largest number that will divide evenly into 54 and 90. So let's quickly find HCF using Euclid's division algorithm. When we apply Euclid's division algorithm, we need to look at the step where remainder becomes 0. The divisor in that step will be the HCF. And if you look at the steps, you can easily see that HCF of 54 and 90 is 18. So what does it mean? It means that the largest possible square pieces that Adarsh can cut out of this rectangular board has a dimension of 18 centimeters. So the largest possible square pieces that Adarsh can cut without wasting any of the rectangular board has a side length of 18 centimeters. So we got the dimension of one such square piece that he can cut as 18 centimeter by 18 centimeter. Now I want all of you to think about this question. How many such square pieces can Adarsh cut out of this rectangular board? Think about it, solve it. I will leave that task to you. Feel free to use your doubt section to ask any questions. We would be happy to assist you. Now this marks the end of Euclid's division lemma and algorithm. So that's all you need to know about Euclid's division lemma and Euclid's division algorithm.